Good day everyone, I am Jovi and Geraldo, and now we will talk about the different rules for derivatives. So we have the power rule, constant rule, product rule, quotient rule, and the chain rule. So I hope you enjoy, keep on watching guys. So the first one, we have the power rule. So we have some function f of x is equal to x raised to the power of n. So x is our variable there and n is the constant. So what is the first derivative of a function? So according to the power rule, it's going to be equal to n times x n minus 1. So this would be the format that we use to find the derivatives of a power rule. So based on this formula, what is the derivatives of x squared? In this case, n is equal to 2. So this would be the derivative of dx x squared is equal to 2 times x 2 minus 1. And 2 minus 1 is equal to 1. So this would be 2x raised to the power of 1. Or simply, this would be equal to 2x. And that's the end of our first example. So let's try another example. Find the derivatives of x cubed and the derivatives of x raised to the power of 4. So this one we have 3x 3 minus 1. So 3 minus 1 is equal to 2. So this would be 3x raised to the power of 2. And the second one is the derivatives of x raised to the power of 4. So this would be 4x raised to the power of 4 minus 1. So 4 minus 1 is equal to 3. So this would be 4x raised to the power of 3. That's how we can use the power rule to find the derivatives of a function. Now try to find the derivatives of x. Go ahead and think about it. So this is basically x raised to the power of 1. So our n there is equal to 1. So we have 1x raised to the power of 1 minus 1. So 1 minus 1 is equal to 0. So 1x raised to the power of 0. And any number that raised to the power of 0 is equal to 1. So this thing is equal to 1. This would be the final answer. Another example is try to find the derivatives of 5x. So if we have a constant and a variable, just move the constant to the front. So this 5 move to the front. So this is the same as 5 times the derivatives of x. So this would be 5 times 1 because x is just 1. So 5 times 1 is equal to 5. So this would be the answer. Let's proceed to constant rule. So try to find the derivatives of 8. So keep in your mind that the derivatives of any constant is 0. One way to show this using power rule is you can rewrite 8 as 8x raised to the power of 0. Derivative of 8x raised to the power of 0 because x raised to the power of 0 is equal to 1. So we have 8 times 0 x raised to the power of 0 minus 1. So 0 times anything is 0. So the whole thing is 0. This would be 0. That's the way we can show that the derivatives of a constant is 0 using the power rule. We will now in product rule. Recall that the product rule says that the derivative with respect to x of the product of the two functions f(x) times g of x is equal to f of x times g prime of x plus f prime of x times g of x. And now, let us prove this result. What I'm gonna do is, I'm gonna let capital F of x is equal to f of x times g of x. And we will use the definition of the derivatives. Capital F prime of x is equal to limit as h approaches 0 of capital F of x plus h minus f of x all over h. But now, I'm gonna replace the capital F function by little f and g. So we can rewrite this as limit as h approaches 0. So instead of capital F, we will use the small letter f of x plus h times g of x plus h minus f of x times g of x all over h. In this case, we're gonna do now to make use out of this is we're going to subtract and add, subtract and add f of x plus h to the product of g of x to the numerator. So we get the limit as h approaches 0 of f of x plus h g x plus h minus subtract the f of x plus h of g of x, so plus we're gonna add f of x plus h of g of x plus f of x plus h of g of x minus, so we left f of x times g of x all over h. This would be the trick to make everything work out. So now, I'm gonna split this couple of terms. So, limit as x approaches 0. So, we're gonna split this into two couple of terms. So, we go first with this. So, f of x plus h of g x plus h minus f of x plus h times g of x all over h. So plus limit as h approaches 0 of the remaining one. So f of x plus h of g of x minus f of x then g of x. So I'm gonna put this little one all over h. In the first limit, I'm gonna factor out f of x plus h, and in the second limit, I'm gonna factor g of x. So this would be limit as h approaches 0. So factor out f x plus h of, so the remaining one is g of x plus h minus g of x all over h, plus in the second one we will factor out the g of x, so limit as h approaches 0 of g of x, so the remaining one we have f of x plus h minus f of x all over h. We're almost there. Now if we look at limit as h approaches 0, we're gonna substitute h as 0 from this expression. So here we substitute h as 0, so we're left with f of x and the prime of g of x, that is just the definition, plus here this is just g of x, and substitute 0 here, we left with times f prime of x, that is also the definition. And now the proof is complete. We get the formula to find the product of the derivatives. So for example, we will find the derivatives of x squared sine x. So our f there is x squared, and our g of x there is sine x. And the f prime of x is we have 2x, so we will just know this using the power rule, and then the g prime of x we have cos x, and we will just substitute it to the expression. So we have f prime of x is 2x times g of x, we have sine x, plus f of x is x squared of g prime of x is cos x. And then we will now factor out the GCF. So we left with x of 2 sine x plus x cos x, and that is the result of the derivative of x squared sine x.